guided practice with position time graphs. We're specifically going to be analyzing graphs of position versus time, but we're going to continue to use the skills that we developed with just graphical analysis in general. So if you remember, when you're doing graphs, you're trying to first identify what's on the axes and think about what it means. Look to see what the slope means. Look to see what the area under the graph means. Since these are all position versus time graphs, this is going to be pretty repetitive, but yet still important to keep that discipline in terms of thinking things through in an organized fashion. Number 1 says, sketch a graph of the car's motion. It's at rest at a traffic light for 3 seconds. It gradually accelerates for 20 meters until reaching a maximum speed of 18 meters per second. Then the driver realized she forgot something at home and slowed to a stop over the next 30 seconds. Then she turns around and heads back home at a constant speed of 10 meters per second. So we're going to make a position versus time graph. So I'm going to draw those axes first. So this is going to be my position. Always label your axes right away versus time. And we want to get this general relationship, right? For a position versus time graph, the slope is my velocity, okay? So if I know that, and I say I'm at rest, that means segment A is going to be at rest, which means it has 0 slope because it has 0 velocity. For segment B, right, we'll call it the next segment, it gradually accelerates. Okay, so that means we're increasing speed from rest, which means that we have to have an increasing slope. Then she slows to a stop. That's going to be segment C. So that's decreasing velocity, which means decreasing slope. But this whole time we're moving away. So it's in the positive direction, right? We're continuing in that same direction. Then the last part, she turns back around and heads back home at a constant speed. So now we have constant speed, which means constant slope. But now because we turned around, that means we're going in the negative direction. So once you've kind of figured out that general situation, I'm going to break my axis up. Now I don't have a lot of information, so I'm just going to pretty randomly, right, put some times here. And I'm going to call this time A, time B, time C, and time D to kind of represent the endpoints of these time periods. So for the beginning, for this first time period, we're at rest. So you have 0 velocity because you have 0 slope. Then we're increasing slope in the positive direction. So I've got to increase my speed during that time. So I'm increasing my slope. Then to decrease my slope, I need to get from this steep slope, and at my end point, I need to have have 0 slope because I'm stopping, coming to a stop. And then all you got to do is connect those 2 pieces. Then we're going to go at constant speed, so we need a constant negative slope to some later position. And you could even make this go down through, because at the beginning you're at a traffic light, you're not at home. So theoretically, then you're going back home, which is even further from the light, right? Back behind where we said 0 was. Now, what do we do about the position versus time, the position axis, the y-axis, in terms of markings? And can we add any specifics? So if we mark some of these turning points, right? Here's one. Here's another, right? If you wanted to, kind of hypothesize this, you could, right? So what would you call these? Well, do I have any information? Well, I know this was 3 seconds, so I can kind of put that on there. 20 meters is where this happens. So I can put the 20 meters on the axis. And it reaches maximum speed of 18. So that's just going to be the slope right here. Is 18, but there's no way to show that on the axes per se. And then slows to a stop over the next 30 seconds. So I know that this here is 30 seconds. So the only thing you could say for TC is that it's, right, TB plus 30. We don't know what this time frame is. It's not given. We could calculate it, but we're not interested in that right now. And then it turns around and heads back home on constant speed of 10. So we know the slope of this one is 10, but again, we don't know what those values are. So in order to finish populating this axis, you want to call this position C, and you can call this position D, and that would be perfectly fine. If you take a look at these graphs, these are all position versus time graphs, and the parts of these questions ask you to rank the graphs on the basis of different quantities. So the first one asks about the distance traveled. So to find the distance traveled, we need to use the position, right? So if you look at this one, we're at 30 meters, and we stay at 30 meters, 30 meters, 30 meters, 30 meters. So that doesn't change. So for A, the distance traveled is 30 meters, is 0, sorry, because you're not moving. Even though your position's at 30 meters, you didn't travel there. For B, you're at 3 meters, and that doesn't change. So the distance traveled, again, is 0. For C, you've traveled from 0 up to 10 meters. So you've got your total distance traveled is 10 minus 0, which is 10 meters. Then D, we've gone from 2 up to 5. So we're using the y-axis. So the total distance traveled is 5 minus 2, which is 3. E, we've gone from 30 down to 1. So the distance traveled is, right, 30 meters, because we take the absolute value. And then for for F, oops, I'm going to squish, right? We start at 0, we go up to 8 and back down to 0. So the first segment I've gone 8 meters, and then I've got another 8 meters. So now my distance traveled is 16 meters total. So if I rank these, then I'm going to get where A is equal to B, right, because that's 0. And then 30 is the biggest distance, and then 16, and then 10, and then 3. So that's how I would rank the distances traveled. So that's for A. For B, what's going to change for B? Well, B is asking for displacement. So which of these values change when you're talking about displacement? Well, displacement is the change in position, and direction does matter. Well, this isn't going to change, right? So the displacement is still 0 because you're not moving. This displacement is still 0 because you're not moving. This displacement is still 10 because you're changing your position from 0 to 10, so that's still 10 meter displacement. And same thing here. So these first 4 don't change at all. But now when you get to E, the sign matters. So this is negative 30 meters because you are going backwards. And for F, if you start at 0 and end at 0, now your displacement is 0 because it's not just how far you've traveled during these segments, it's the change in that position. So the ranking, the beginning doesn't, so the beginning changes also because now this is negative. So we're going to say that it goes C, right, is the biggest, then D, then A, B, and F are all 0. And last, we've got this negative value. Now listen, the negative doesn't mean less than 0. So technically, it's not actually less. But if we're ranking it in terms of a scale, right, then we can put that as a negative. But that's arguable, of course. All right, next. C asks about the greatest average speed. So average speed is distance divided by time. So if the average speed, right, when I want to calculate average speed, it's total distance over total time. Well, the total time for each is 10 seconds, right? That doesn't change for these. So if that's true, then the average speed is going to be proportional to the distance. If that's true, we don't have to even do any calculations. If it's proportional to the distance, then we're going to just use the same answer as in A. And that's all you have to do. That's really simple. For D wants to know about the greatest average velocity. Okay, so if I'm going to look at the average velocity, velocity is displacement over time. Now notice that the V, there's no difference between average speed and average velocity in terms of what you're noting. Sometimes people will show average velocity with an arrow on top. That this line though generally means average, or you could put V average like that. Or you can just write out the word speed and velocity. So average velocity is proportional to displacement. And since we figured out displacement in B and the times are all the same, right, then we can say it's the same answer as B. So it's good to, like, if you can, reduce the amount of actual calculating work you have to do by thinking things through and making sure you understand the general definitions and relationships. And the last one as E, rank each case from the lowest to the highest acceleration. So when we didn't really talk about acceleration yet. So the acceleration is the change, right? Acceleration, if we look at the definition, is the change in velocity over the change in time. And again, the change in time is the same for all, so that doesn't really matter. So all we have to do is look at our change in velocity. Well, now let's look back at our graphs. This isn't moving, so acceleration is 0. This isn't moving, so acceleration is 0. This has a constant speed, therefore acceleration is 0. Same with D, it's a straight line, the slope is velocity, therefore it's constant speed, so acceleration is 0. E is also acceleration of 0 because it's a straight line. Yeah, it's going in the negative direction, but that does not influence that it has no acceleration. This one, though, is changing speed from the beginning to the end. It's changing its direction. So what you've got here is an acceleration. This one is accelerating because it has a positive velocity initial and it's got a negative velocity at the end. Now, if change in velocity is V final minus V initial, then I would put negative V for my V final and subtract my positive V in the beginning, right? So this becomes negative 2V. So if actually my change in velocity is some negative value, it doesn't even matter what it is because all the rest are 0. All you can see is that you're going to have some negative acceleration because you have a negative change in velocity. That means that A equals B equals C equals D equals E. Those all equal 0, and those are all greater than the acceleration of F because F is going to be some negative acceleration because acceleration is proportional to delta V, and delta V is a negative number. Examine the graph to the right. Describe the motion of the object in as much detail as you can. So looking at this first segment here, your starting position is 10. So I would say starting at 10 centimeters. The object moves with constant speed for 1, 2, 3 seconds until reaching 20 centimeters, where it stops. Right, so here the 0 slope, so it's at rest. It remains at rest for 1, 2, 3 seconds. When it begins, what does it begin to do? So at this point, you have a negative slope. And a negative slope means moving a negative speed and a negative velocity, and a negative velocity means moving backwards. So it begins to move backwards at constant speed. And so it takes from 6 seconds to 16, 17, 18, for 12 seconds when it reaches the, let's see, 2, 4, 6 centimeter mark. That's it. That's all you got to do. Now, you could get into more depth if you wanted to actually calculate the slope. You could figure out those speeds, but this is a really good description. You mention in each piece what type of motion it is, at rest, increasing, decreasing, or constant, how long it did it, and where it was, and that's a pretty good start. All right, last one. At the right is a position time graph for two objects. So which of the following are true? So before we look at the answer choices, let's just get an understanding of what's happening. A, right, for this position time graph, has a curve. And this curve starts with a very shallow slope and ends with a steep slope. When you start with a shallow slope and end with a steep slope, that means that you've increased your speed, right, for A, in the positive direction. For B, B has a straight line, which means that it's going to be constant speed because it has a constant slope, and that's in the positive direction as well. All right, so then what's going on right at that point of intersection? At this point, that it's at the same place at the same time. So it took 5 seconds for A, right, to catch up to B, right, because now they're at the same exact place. So it says object B has a greater velocity than A for the entire time interval. Well, that's not true because the slope here for A is less, but the slope here for A is more than B's slope. And if you're not sure about that, you can just take a ruler. Here's B's line, right? If I bring that over to A, well, I can see right in the middle they have pretty much the same slope, but here it's less and here it's more. What we're doing is we're actually examining those tangent lines, right? At 5 seconds, object A has a greater velocity than B. Is that true? Well, let's use our ruler again, right? You can see A's line segment right at that point is tipped upward, which does mean it has a greater velocity. The velocity of A equals, well, obviously they can't both be true at the same time. A is not constant velocity and B is not accelerating. So the only one that's true is B.